For this demo, you'll need ammonium chloride, hydrogen peroxide, 1 cup per visitor with a straw, 2 flasks of water, and yeast. Alright, so today I'm going to be teaching you guys how to do the exothermic and endothermic demonstration. And so this is a really simple demonstration where we demonstrate both the hot and cold reactions. So the first one you're going to do is the exothermic reaction. And you're going to take about a teaspoon or half of that of yeast and place it into a cup. Next, you're going to want the visitor to hold the cup in their hand so that they can feel the reaction that's about to happen. You're going to pour in a little bit of hydrogen peroxide, just enough to cover the yeast, about ½ inch. And then you're going to ask the visitor to take a straw and stir the cup. Immediately, you should see some bubbles forming. And what's happening is the hydrogen peroxide is decomposing into water and oxygen gas. If you feel the bottom of the cup should be warm, and this means that the reaction is exothermic. So the energy that it's taking to break up the hydrogen peroxide is less than the energy that it's taking to make the new products. So that extra energy that's being released is coming off in the form of heat, and that's why the cup is warm. The yeast in this reaction is just a catalyst, and it's not actually doing anything to form the product of water and oxygen gas. The next reaction is the endothermic reaction, and this one is going to be cold, so just the opposite of the exothermic reaction. You're going to have 2 flasks. They're both going to be filled with water, but one is just going to be a baseline test so that you can see how the normal water feels in comparison to the colder water that we're about to make. All you have to do for this one is take about a teaspoon or so of ammonium chloride and pour it into one of the flasks. Stir for about 10 seconds or so, and then ask your visitors to feel the bottom of the flask. It should be a lot colder than the baseline water. And the reason for this is because it took more energy for the products to form in this reaction than it did to break it up. And so the extra energy that it took to make the products had to be absorbed from the water, and it absorbed the heat from the water and cooled the entire flask as a whole. A good question to ask visitors is how this applies to our daily lives, or what kind of reactions we see commonly in the world that are also exothermic and endothermic. An example of an exothermic reaction is fire, or our bodies ourselves make exothermic reactions all the time, and that's why we're warm. And so you can find more examples on the sheet provided, and that's all you have to do.
Thank you for volunteering at the Fleet Science Center.